Hi friends, we'll solve problem on variable acceleration. Just see what is given in problem. A particle moving in positive x direction with a equal to 100 minus 4v square meters per second square, where v is in meters per second. Determine the time interval and displacement of particle when speed changes from 1 meter per second to 3 meter per second. See what is given. If we write equation of acceleration is 100 minus 4v square. This is meters per second square. This is equation number 1. Now when velocity of particle changes from 1 meter per second to 3 meter per second, you have to find out time interval and displacement of particle. That means when speed changes from 1 meter per second to 3 meter per second, what you have to find out, what is the time interval delta t and displacement. You have to find out delta t and delta x, time interval and displacement of particle. That means when a is given as a function of velocity, we will substitute acceleration in terms of delta t in terms of delta x. That means a you have to write for first part in terms of t, for second part you have to write a in terms of x. Therefore, what we will do here, first part if you want to find out, that means for delta t, I will write a in terms of dt. A in terms of dt is written as what? dv by dt, simple, equal to 100 minus 4v square. As this 100 minus 4v square, that means if I take this dt on right hand side, so what will get here? dv equal to 100 minus 4v square dt. If we will integrate this equation, now integration in this case, as velocity limit is given 1 meter per second to 3 meter per second, we'll solve it as a definite integral. That means we'll put here limits of integration so that easily this time interval delta t is possible. Now if we'll integrate it, integrating this equation, integral of dv, but here dv if we'll take as an integral, on the right hand side there is a still term of velocity. Therefore 100 minus 4v square, again I will take on left side 100 minus 4v square. That means integral of dv upon 100 minus 4v square equal to integral of dt. If we integrate it, limits of integration are important. Here velocity v varies from say v1 to v2, where limit of velocity is given in problem 1 meter per second to 3 meter per second, and this one you can say time t varies from t1 to t2. If we integrate this one, now this one is in which form? This one is integral of dx upon a square minus x square. Therefore, to solve this integral, you must know a formula from mathematics, where you can say this one formula is what? To find out this integral of dv upon 100 minus 4v square, you must know integral of dx upon, this is 100 minus 4v square, that means some a square minus x square, dx upon a square minus x square, this is 1 upon 2a log of a plus x divided by a minus x plus some constant of integration. That means our equation, if you want to solve now, integral varies from v1, v1 is 1 meter per second, next limit is what? It varies up to 3 meter per second. When velocity increases from 1 meter per second to 3 meter per second, that means limits of integration are known. Now dv upon, what you are getting here is 100 minus 4v square, which is not in this form. Therefore, if I take this 1 by 4 from denominator, suppose common, if I take 1 by 4 common, so what will you get here? This one 1 by 4 common, Now in denominator it is 100 divided by, or from 100 if you take 4 common, I get 25. From 25, that means it's easy to write as 5 square minus this one is v square equal to, this is integral of same dv upon 100 minus 4 square. I have written like this. On the right hand side, t varies from t1 to t2, integral of dt. Now 1 by 4 as it is. Using this hint, what will get here? 1 upon 2a. That means a is what? A is nothing but 5. That means we'll get what? 1 upon 2a. That means 1 upon 2 into 5. 1 upon 2a. ln log of a plus ax. That means 5 plus v divided by 5 minus v equal to integration on right hand side. Integral of dt is t, upper limit t2, lower limit t1, that means t2 minus t1. As we are using limits of integration, you will not get constant of integration in this one. Now if we will substitute here this one limit of integration where velocity varies from 1 meter per second to 3 meter per second. Now it becomes 1 upon this one 5 into 2 10, 10 into 4 is 40, that means 1 by 40 ln of, now upper limit if you substitute, it is 5 plus 3, that means 8. At 5 plus 3 divided by 5 plus upper limit is 3, 5 plus 3 8 divided by 5 minus 3, that means what you will get here 2, that means can you say it is 8 divided by 2 minus lower limit. Now lower limit is 1, 5 plus 1 becomes what? 6 divided by 5 minus 1 becomes what? 4, and 1 by 40 common equal to t2 minus t1, that means what? Delta t. Now using calculator if you calculate this, delta t easy you will get, where ln of you can say 4 minus ln of 6 by 4 and total what value will get divided by 40, what will get some time interval in which this speed changes from 1 meter per second to 3 meter per second. This if you calculate using calculator comes out to be 0.0245 second. This is a solution of first part of problem. Find time interval when velocity changes from 1 meter per second to 3 meter per second. Second part of problem, which one is equally important. Second part is what? Find displacement of particle when speed changes from 1 meter per second to 3 meter per second. For that one, basic equation, what you know, equation of acceleration, what is given in problem. This is we are solving second part of problem. What you know, acceleration a is 100 minus 4v square. Now you have to find out what? Displacement when velocity varies from 1 meter per second to 3 meter per second. That means this acceleration a you have to substitute in terms of position, in terms of displacement, where substitution a is what? v dv upon dx equal to 100 minus 4v square. Now here term of velocity is on right side, term of velocity on left side, dx is in denominator. That means if we rearrange the term, v dv upon 100 minus 4v square, this is in denominator, equal to dx. If you integrate this equation, what will get here? Integral of v dv divided by 100 minus 4v square equal to integral of dx. Now limit again given, you have to find out what? This displacement when velocity varies from 1 meter per second to 3 meter per second. Therefore, now if you integrate it, v dv, for this one, this is in what term? Integral of x dx upon a plus bx square. Therefore, integral of x dx upon a plus bx square is 1 upon 2b log of a plus bx square plus constant c. That means if we integrate this one, what will get here? Integration, limit of integration 1 to 3. This one becomes 1 upon 2b, where b is what? B is nothing but 4. Therefore, if we integrate 1 upon This one is negative because this is a 4 term. Which one is what? V square. 4v square. That means a term of b becomes what? 4. Therefore minus 2 into what? 4, and then log. Log of this equation becomes what? This is 100 minus 4v square, and limit of integration varies from 1 meter per second to 3 meter per second, and this one becomes x2 minus x1, where limit is what? x1 to x2. After integration, what you are getting? 1 upon minus 2 into 4 log of 100 minus 4 square, limit of integration. Now, if we will substitute your limits of integration, what we will get here? We will find out this x2 minus x1 means delta x here becomes what? Minus 1 upon 8 ln of, now upper limit if we will substitute, it becomes 100 minus 4v square. That means here v will substitute 3, so what will get here? 36 divided by 100 minus 4. If we calculate using calculator, this one comes out to be positive answer 0.05068 this much meters. That means here in such problem you must know again some formulas from mathematics, where one formula what we have discussed we have written also as a hint, 1 upon 2a. That means integral of dv upon a square minus x square, or second one integral of x dx upon a plus bx square. Simple formulas of integration are must. Using that one, direct solution is possible. So what you are getting? Some time interval you are getting when velocity increases from 1 meter per second to 3 meter per second, and you are getting displacement when velocity increases from 1 meter per second to 3 meter per second. Thank you.